Alright, for number 18, notice that I used different reference points, and the only reason for doing that is the a value being 2/3. So I based it on the denominator, 3, and remember the parent function is x squared. So negative 3 squared is positive 9, and so is 3 squared. And that's why you see these 2 points right here as my reference points. The a and the k affect the y, and that's why you see this. And then, so when you multiply 9 times 2/3, you get 6. 6 plus 1 is 7. Okay, and so that's where you have this. So now I'm going to plot the points. So negative 3, 7. Be back here, and 0, 1, and 3, 7. Okay, connect them, and you are done. So for number 19, it's a cube function, a cubic function. The reference points are there, and then the h is positive 3, the y is positive 1. So we have 3 minus 1 is 2, and then 1 minus 1 is 0. 3 plus 1 is 3, and then 1, and then 3 plus 1, 4, and this is 2. This point right here is the inflection point, or point of inflection, which is now this one, and this is the point where the graph changes direction. Okay, let's go ahead and plot what we have. 2, 0, 3, 1, and 4, 2. And it goes something like this. And then this one curves the other way, like that. Okay, so the absolute value function is the V shape. The reference points are right there, and then h is positive 5, and that's why you see this positive 5 is this one right here. A is negative 5, that's why this is negative 5y, and then k is negative 3, and that's why that's negative 3. So now we're going to transform the points. So 5 minus 1, 4. Negative 5 minus 3, negative 8. And then 5, negative 3. And then 5 plus 1, 6. And then negative 8 right there. Okay, so let's plot the points. So 4, negative 8. 5, negative 3. And 6, negative 8. So it's a really skinny V shape. So remember, this is not a curve, it's a V shape. So number 21, we have to fix a little bit, change the way it looks, just so that you have it in the same format that we're used to seeing it for transformations. So I'm going to switch the x and the 9, switch places like that. And then I'm going to factor out the b. So the b is negative 1, right here. So that becomes minus 9. Now I didn't have to write the 1 there, but I don't know why, but you don't need the 1. Anyway, so the reference points for a square root function are 0, 0, 1, 1, 4, 2. The b value is negative 1. Now remember, we do reciprocal of b, but because it's 1, well, reciprocal of 1 is 1. So that still looks like negative x, and then we're going to add 9, because h is 9, and for the y's we're going to subtract 3. So opposite of 0, 9, plus 9, 9, and then 0 minus 3, and then opposite of 1, plus 9 is 8, and 1 minus 3, negative 2. Opposite of 4, negative 4, plus 9 is 5, and then 2 minus 3, negative 1. So now we're going to plot this. So 9, negative 3, 8, negative 2, and 5, negative 1. And I just put in a 0 because 9 minus 0 is 9, and the square root of 9 is 3. 3 minus 3 is 0. So even though this is not on our list, it's part of the graph. So I'm just sketching it so I can get a better, so I know exactly where it crosses on the x-axis. So it's going to go something like this, like that. So they want you to write a function for where the parent function is x squared, f of x is x squared, with these 3 transformations right here: down 5, left 4, and reflecting over the x-axis. Well, reflecting over the x-axis is a being negative 1. So I'm going to put a negative there. And then to the left 4 means x plus 4 squared. And then down 5 means minus 5. That's your k value. And that's it. So for 23, they want you to do f minus g. So the order matters for subtraction, right? So I put f of x first and then minus g of x. I'm going to distribute the negative, so that's going to give me 2x minus 2 minus 4 plus x, combined like terms. So that's going to give you 3x minus 6. So 24, it's f over g, so that's what I put there, f of x over g of x. Nothing to simplify, so this would be the f over g of x. For the domain, you look at the denominator and we see that x is all x such that x cannot equal, 3 over 7? Because that makes the denominator 0. Alright, so for 25, they want f of g of x. And remember, before we do anything, we identify the domain of the inside function. In this case, the inside function is g of x, because g of x is going to go into f of x. So I look at that function and identify its domain. So here's the function. The domain of this function is all reals. Okay, so what that tells me is that I'm coming into this new function with all reals. Okay? So now I'm going to do f of g of x. So that would be f of g of x. Remember, this is the other notation for fog. So you take x squared, and in place of the x squared you put x minus 2, the g of x. And so you can leave it like that, or you can multiply it out. Same thing. So it's either this one or this one. And the domain of the resulting function of f of g of x is also all reals. There's no restriction on the domain. For number 26, f of x is the inside function, because it's the second one right here. So I identify the domain for this one first, because this is the domain I'm coming in with. These are the values of x, the ones that are, the domain for this one. These are the ones I'm coming in with. So the domain for this is all reals, no restrictions. So now I'm going to do g of f. So g of f is, I take the g function, and in place of its x, I put f of x, so x plus 3, like that. So we simplify, x squared plus 6x plus 9, and then we had a minus 9, so the 9's are gone, so you're left with 1 over x squared plus 6. So this is the composition right there. Oops, is it plus 6? Yeah, plus 6. Oops, 6x, sorry, forgot the x. So I can factor it, and I see that x, the domain for the composition is that x, all x such that x cannot equal 0 or negative 6. Okay, so that's the domain, and either one of these is fine for the function, the one for the composition, and then this would be the domain. So for 27, the inside function is g of x, and so here's the function g of x. Its domain is all reals. So that's what we're coming in with, all reals. So now I'm going to do f of g of x. So you start off with f of x, and in place of its x, I'm going to put in g of x, the inside function, plus 1. Okay, so here is the composition. We can simplify. 1 minus 1 is 0, so that we end up with x squared like that, which is x. And again, the domain is all reals. Alright, for the inverse, there are 4 steps. First, we switch out the f of x, make it a y. Oops. And then we switch the x and the y. And now we solve for y. So I need to square both sides. So I get x squared plus 7y equals 7y plus 8. I subtract 8 from both sides, so that leaves me with x squared minus 8 equals 7y. Then I divide by 7. Okay, so I have y by itself now, right? So now I switch it out and make it f inverse of x. So f inverse of x equals x squared minus 8 all over 7. Okay, another inverse problem, inverse function. So we make the f of x equal to y and write it this. And then the next step is we're going to switch the x and the y. So make sure you, so the left side is now x and the right side is 8y minus 1 over 3y minus 4. Okay, make sure you switch out both x's into y's. So now we're going to solve for y. Okay, so first thing I'm going to do is multiply both sides by the denominator just to eliminate the denominator. So on the left side, I'm going to do the right. So over here I'm going to put parentheses, so 3y minus 4. And then over here I'm going to squeeze in 3y minus 4. Okay, so on the left we distribute the x, so it's 3xy minus 4x. On the right side, this cancels, so you're left with 8y minus 1. So I'm going to put my y's together by moving this term over, and then this one to the right side. Okay, so right here, this is gone. I've got 3xy minus 8y. I cannot combine those because they're not like terms, right? Right here, that's gone. So it's 4x minus 1. So I can factor out a y from both terms on the left side. So I have 3x minus 8 equals 4x minus 1. Now I can divide by 3x minus 8. Oops, minus. And then that cancels with that. So that now y is by itself, right? So f inverse of x equals 4x minus 1 over 3x minus 8. Now we have, remember at the beginning, the original function, they gave you this restriction because if x, just because of that domain there. So we know x cannot be 4/3, so I'm going to do the same thing here. X cannot be 8 over 3, because that would make the denominator 0. Okay, another inverse function problem. So y equals x cubed minus 4. Whoops. Minus 4, I'm going to add 4 to both sides. Oh, I'm sorry. Switch the x and the y. Now I'm going to add 4 to both sides. Okay, so I need y by itself, so I'm going to take the cube root of both sides. That's a 3 right there. And so on the left side I have the cube root of x plus 4. On the right I just have y. So switch the notation to function, inverse function. And there's the answer. So 31, it's asking if the graph is a one-to-one function. The answer for A is no, and the reason for that is because it fails the horizontal line test. It doesn't pass that test. And B is yes, because it passes the horizontal line test. If you pass the horizontal line, you only touch one point at a time. And that's it.